Look at linear regression, your MT5, LT5 seminar. Before you start, do the first 5 questions so you understand where we're going with this lesson and get your knowledge ready for what we're going to be learning. What we're going to be doing today is we're going to write equations of line of best fit. In other words, we're going to write the equation of a line using linear regressions. And we're going to determine how well our functions fits data set. Because in real life, the data doesn't correspond exactly to a straight line, believe it or not. And so what we're going to do, we're going to use technology, your Desmos calculator mostly, and we're going to use it to find the precise equation of a line. Even when you take a statistics class, we don't make you do linear regression by hand anymore. It's a complicated formula, but we're going to just use technology to do that. Now, what we are going to look at in applying that technology, we're going to look at the correlation coefficient. Remember, the correlation is how well the data fits the line. And we use the letter R for that correlation. So R is 0.02 in this case. Notice that's a very weak. You can hardly draw the line, figure out which way the line should be drawn. Now, if we have a moderate where I can see where I'm going to draw my line, I'm just not quite exactly sure, and I got points that are well above or well below my line. And then a strong correlation coefficient, notice all those points are pretty darn close to my line. A perfect correlation would be 1 or -1. 1 if it has a positive, and -1 is negative. So it's not like -1 is worse than 1. They're exactly the same. It's just one is going down and the other is going up. And then a 0 correlation coefficient would mean the data doesn't fit at all. You won't have that very often. You want a correlation coefficient when you're doing research to be relatively strong. If you're in medicine, you're going to come up with this new medicine. Your medicine better affect what it's trying to treat. If you're going and getting this medication and introducing something to your body that your body isn't used to, it better cure what it's supposed to cure. So in medicine, they want a correlation coefficient of at least 0.9, probably 0.98. Whereas in social science, like education, where you have a lot of other things affecting it, when we do research and we're looking for something that affects it, like how does this reading program make your students better readers? They're looking for a correlation coefficient like 0.8, 0.7, something that shows it has some effect on it. You don't want a negative one that makes them worse, but you want a positive one. Now, we can apply that in this problem. Notice, let's take a look at it first. The table shows Jackie Robinson's total hits during each season of the Major League career. We're going to use our Desmos calculator to write an equation, line of best fit for the data. Then we're going to find and interpret the correlation coefficient. The nice thing is the calculator does everything for me. I just have to know how to use the calculator to find that. So first off, when I do this problem, let's define a variable. I'm going to let X be the years since 1947. Because he came into the league in 1947. There was no 1946. And then he retired in 1956, so really can't go anything beyond 1956. And Y will be the hits per year. And if we notice, we definitely see a negative trend there. He started with 175, he went up to 203, and then he dropped down to 98 in his last year, which is still really, really good. So here's what we're going to do. We're going to plot this data. Now, to plot the data, you open up Desmos, and you press your table. And I'm going to start in the year 0, so I'm going to go 0. Then I'll press 1 and 2 and so on. Notice after I get a trend, Desmos is smart enough, it'll help me put that in. Now I've actually made this table for you and I put it in Google Classroom and on your textbook. So I'm just going to open that up right now so we don't spend all our time typing the data in. Now I want to find the equation of line of best fit. First off, notice your table uses x1 and y1. So when I do that, I have to type in y1. Not that big a deal, but it is a little different. So I go y1. Notice when I do y1, it automatically puts the 1 as a subscript. So I don't have to worry about that. Now when I do a line of best fit, I want to use my tilde. So I have to go to my keyboard, or on your keyboard, press the tilde. And then we'll do the same thing. We'll go m x1 plus b. Now notice you can't see your graph, can you? I have to adjust my table or my window so I can see my graph. Yeah, I can zoom in, but then I'm only going out to 100 years, aren't I? I don't want to go out to 100 years. I just want to look at the first 10 years or so. So here's what you do. You press the wrench up in the right-hand corner of Desmos. And we're going to type in our x-axis. Now, I want a little bit of a margin. I don't want to start at 0. So I think what I'll do is I'll start at -10. And then we're going to year 9, so maybe I'll put in 15. So that way, oh, now you can see we have a graph that looks a lot better, doesn't it? And then if I'm going to go from 10 to 15, that's 25 numbers. I think my step can be 1, but I think I'll make it 2 just to be on the safe side, so that way I can see my data points. And you can actually label in Desmos, because this will be the years since 1947. And then I'll do the same thing for my y-axis. Now remember, his least was 98 hits, so I want a little bit of a margin there. So I'm going to start my graph at 75. His most was 175, so I'm going to go up to 200. And then maybe I'll count by, let me see, that's 175 to 200 is 125. So how about if I put a tick mark every 10? That way I can see it. And then I'll label, that'll be the hits. And then I click on that. Now I can see it, and maybe I'll still adjust my graph so I can see it. Now notice I can see my line goes through those points. I have some points above the line, some points below the line. That looks pretty good. My equation, notice I've got my equation in the second box underneath my tilde. It says my slope is -10.3. So I'm going to say y, for my equation of line of best fit, I'm going to say y equals -10.3x plus, and then it says 195.2. And no, remember he started, and he actually got better the first couple of years with the hits. And then he had a significant drop off after those first 3 years. But then he rose up again. And so our data isn't quite going to be perfectly on the line. How well is it on the line? Well, look at your correlation coefficient. My R is -0.8. -0.8022 if you want to be exact. But I'm going to say -0.8. Which means it fits it pretty well, doesn't it? In social science, I'd say that's a pretty good fit. We can predict it pretty darn close depending on the years and what I would plug in. And there we have it. Now let's take a look at our second example. I want to look at the online sales on Cyber Monday since 2009. So once again, I'm going to let X be the year since 2009. This time, I don't really care about the R value. I want to estimate what the sales will be in next year in 2025. Notice my data only goes up to 2016 because we don't have everything beyond that point, although we probably should have with computers and everything. And Y is going to be the sales in millions. So you can go to Google Classroom again, and I already loaded your table for you, so you don't have to type the table in, but you can just type it in just as well. And this time I think I'm going to start by adjusting my table right away. So I'm going to start at -10 again, and I'm going to go to +10, maybe a little bit further. Let's go, because we started in 2009. I want to go to 2025, so let's have that go up to 30. And 34. So I'm going to have my step be 5. And we're going to say years since, what did we say, 2009? I forget. Yes, years since 2009. Need my numbers there. My y-axis, notice 887 is my smallest. So what I'll do is I will start at 500. And I want to go up to 2,600. Let's go 3,000. Probably could have just as well started at 0 on this one. And then 3,000 divided by 10 is 300. I'm going to round that up. I'm going to go 500. And this will be my sales. Now I can see my data and look at it. It looks kind of linear. Looks like it curves a little bit, doesn't it? So let's find the equation. So I'm going to go y1 tilde m x1 plus b. And notice my R is 0.99. That's a pretty darn good fit, isn't it? So my equation is y equals 254.5x let me say, probably could have just rounded that, but I'm going to say 254.5x plus, and we're going to say 778.5. That's my equation. They didn't ask me for that. I don't know why I wrote it down, but now I want to know what's going to be the sales in 2025. Well, in other words, I want to find what X is. X is going to be the year since 2009, so I'm going to take 2025 and I'm going to subtract 2009. And 25 minus 9, well, that's 16. So what I'm going to do here is I'm going to replace X with 16. I'll do this on my calculator. So I know M, now I'm just going to type that in. So I'm going to say 254.51 times, and we said 16, plus 778.5 0.58. I'm going to round it to the nearest whole number. I'm going to say I'm going to expect the year in 2023 to be about 4151. So in 2025, we predict the online sales will be, what did we say, 4851 million. Now, is that accurate? It could be, but we're kind of predicting, like 9 years from 2017 or 2016. Well, we know in 2020 we had COVID. That definitely affected our data. And then what happens to the economy? I'm guessing the economy will have a great big influence on this answer. If we have a good economy, it might be higher. If we have a poor economy, it could be significantly lower. Maybe something else happens that sends people back to the stores. If our delivery service would go on strike, it would be significantly lower, and things like that. So it's an estimate. We can't really say it's true until it happens.